My name is Thomas Brott. I come from Chalmers University in Sweden. I'm a maritime human factors guy, so I'm a psychologist, and that's my approach to this. Another sort of controversial topic of ships showing intended routes, and also something about route suggestions. So I'm going to start out in May 2003 in the Baltic Sea, when the Chinese bulk carrier Fu Shanghai left Ventspils in Latvia in the evening with 6,000 tons of fertilizer destined for China. A couple of hours later, the container vessel Gdynia left the port of Gdynia destined for home, and they unfortunately encountered each other north of Bornholm the next day at noon. And the encounter was not so happy, resulting in the loss of the Fu Shanghai, which sank at the position. And I just want to look at the final stages of this accident, because I think it bears some interest to what we are talking about here. So we are having about 12 o'clock, which is about 18-20 minutes before the accident, the actual collision. Two ships are approaching. It's a beautiful day, it's light winds, it's good visibility, sun is shining. Fu Shanghai is heading southwesterly here with some 15 knots or something. Gdynia is coming in this direction with about approximately the same speed. At the point 1 here, 12 o'clock, the Gdynia is for the first time using the ARPA radar and plotting the closest time of approach, which is 4.4 nautical miles here. At the same time, the master of the Fu Shanghai, who has been plotting Gdynia for some time, also with the same CPA. As the time goes on, the ships are looking at each other. There's no connection made. At the point 2 here, the master of the Fu Shanghai is sounding the horn to make sure that the Gdynia is actually going to obey the rules of collision here. Fu Shanghai is, of course, as you all know, the stand-on vessel, and the Gdynia is the giveaway vessel. If we continue, move a bit ahead here at this point 3 at 12:30, the master of the Fu Shanghai stops the engine because he can't see any change of course in the Gdynia. And the Gdynia at this point is turning the wheel. He makes a small course change to 360 at 12:11, and 12:15, 3 minutes before the collision, he makes the wheel hard to starboard to try to evade the maneuver. But of course it's all impossible, because that maneuver should have been done a long time ago. And I'm sure you also ask yourself why this accident happened. It's an accident that never should have happened. Everybody had done what they should have done according to the collision rules of the collision. This accident would never have happened. So this is actually the bridge of the Gdynia. The second officer was probably sitting in one of these seats. And as a psychologist, it's my job to try to figure out there was an accident. And it did happen. It shouldn't have happened if everybody would have done. The rules are there, the rules are clear, and there's no actual reasoning. Why did it happen? When you read accidents investigation reports, which I often do, you often find, you come to that point where you see that there is a very clear technical description of why an accident has happened. But there is no actual explanation to the crucial point, why did it happen? Why didn't the second mate on the Gdynia actually react the way he should have done? That would be expected. These are the kind of accidents that are discarded as human error. You all know that the majority of accidents at sea, as well as in any transportation or in complex environments like process industries and medical hospitals, etc., most of the time are due to some kind of human error. Human error is not a cause of failure. It is the effect symptom of some deeper trouble. Sidney Durkee said. Human error is not the conclusion of an investigation, it's the starting point. And human error is not random. It's systematically connected to features of people's tools, tasks, and of the operational environment. It's no surprise. We are all human. We all make mistakes. We had one of my colleagues at the conference with shipmasters had these kind of mentometers that you used yesterday, and asked the shipmasters, those of you who has ever fallen asleep on your watch, can you please press the A button? You imagine the result? It was almost 100% that pressed the A button. If you would ask them to raise their hand, you would probably not have gotten that result. So we make mistakes. We misunderstand. We mishear things. We think about other things. We are stressed. We fall asleep. These are the realities of the world. So the question is, can we do something with the tools and the environment on the ship bridge to help this human that is standing there, trying to do the best he can? Complacency is a word that's often mentioned in theoretical accident literature. A feeling of quiet pleasure, security, often while unaware of some potential danger. I imagine that the second officer of Virginia was sitting in that chair, maybe not even seeing the Fushan as she was approaching, because it was a little bit difficult to turn backwards. Out of sight, out of mind, somebody said yesterday. There is another word that is called confirmation bias that has to do that. If you have once made up your mind about how the situation is about to develop, you're actually seeking for confirmation facts that will confirm your idea. And you're unaware of that, you're trying to discard information that is disproving this particular point of yours. This is a picture that is only 100 years old. Not very much information was to be found on the bridge of this ship. Most of the information and the knowledge was in the head of the mariner in terms of rules of thumbs. In a modern ship, you have all the information available to you. There's very seldom a reason to say that you didn't know this. But the problem is that once you get in a stressed situation, you have something that called cognitive tunneling is happening. And I'm sure that you've all experienced this because you all have a computer. And in your computer you have a hard disk where you've sorted all your data in different folders. And when everything is nice and calm, you can easily find the data that you're looking for. But if you become stressed, like if you need to find a picture while you're doing a presentation, or if somebody asks you, quickly, can you give me that piece of paper that you have there? And you're trying to find it, and you can no longer think. You can't find the information in your own computer. That is cognitive tunneling, and it happens to all of us. So this is the picture we use in the maritime human factors. We are the human factor here. We look out the window, we collect analog information, we look at our screens and at our numbers from the information displays, we listen to the sound coming in, we feel the vibrations and the motions of the ships. All this has to be integrated into what we call the situation awareness, which is then in 3 levels. The level 1 is that you have to actually see the thing, the information. The level 2 is that you have to comprehend the information. What does it mean to me? And level 3 is you must be able to project it some 3, 6, 12 minutes into the future. What will happen if things go wrong? So if we look at this instant again, with the accident with Zhejiang and the Fushan Hai, I imagine that the master of the Fushan Hai, as he was going down his planned voyage route, and he was seeing the Virginia on his port side, he was sort of thinking, okay, I wonder where she's going. I can look in my AIS, I think she's destined for Hull. Will she go the Beltway, turning just like me down here, or will she cross over and go for the Sound? He wouldn't be able to know that. And the same thing would be on the Virginia. What is happening with this ship? What's the intention of that ship? So the idea is, with the route intentions, that on your atlas you should be able to right-click on a target, like that, and select from the contextual menu, show intended routes, and you would see the route that was stored in the computer, navigation computer of that ship. So you can imagine that you would have some kind of time slider also, so you can move ahead in time using the speed and course of the ship along this route, and you can actually get some kind of position from where there's a possible collision or not. Or maybe even better, you should be able to do this automatically, that somehow there is a calculation going in the background that calculates CPA and TCPA, that warns you that there's an upcoming collision possibility. The intended routes, we are elaborating with different things, 4 to 8 waypoints ahead of the present position, maybe a time measurement, 30-40 minutes, or 10 to 15 miles ahead. That could be discussed. Some kind of distance ahead, ship would be transmitting their intended routes to the AIS message. So we have sort of a look at the time scale here. We talked about the predictor yesterday. That has to do with physics and inertia of the ship. So we're on a very short time scale. You can actually predict what the ship physically will be, whether and then you have the tactical route exchange within maybe 30-40 minutes, and then you come into voyage plan coordination, which is something we're looking into in the Mona Lisa project. So these are some work that are going on. We've done with our colleagues in Denmark. So we are looking at how to display this intended routes. These are an early visualization of the limits of places where the CPA has been CPA threshold has been reached. This is another calculation. So we have one ship northbound, the old ship, the red line here in the northern part of the sound. We have another, the green ship is going the same way, and you can see calculations is being done maybe once every minute. And in this case, the calculations are reaching the 0.5 nautical miles threshold for CPA. There is another situation where the red ship is a little bit ahead of the green ship, but as the red ship is turning port here, crossing the bow of the green ship, there is a violation of the threshold of the CPA. So we are testing these things in the ACCSEAS project in simulators most of the time, of course, because these are not the kind of tests you like to do with real ships. So we are having 3 areas that we're actually looking at. We're looking at the Humber East 3 area, we're looking at the East Anglia Windmill Park, and we're looking at the TTS entrance outside Rotterdam. So, for instance, to see the area outside East Anglia, with the planned East Anglia area, if we look into the detailed plans of Vattenfall and Scottish Renewable, who owns this park, we can see that they're actually planning to do some kind of the corridors in there to allow for ships. So we have the P&O ferry between Rotterdam and Hull, the red line here, that's her regular route going back and forward. And we can imagine that if we also have very dense traffic down for the TTS to the Dover Strait, we will have some problems here with collision avoidance. How do you, as a giveaway ship, do collision avoidance in this narrow area, or in this case here? So there's going to be a problem. We envision. This park is not there yet, but we are building it in Flensburg, in the Flensburg simulator, so to see what will actually happen. And we will try to do this as a baseline, we will try to do without the intended routes, and we will try to do it with intended routes. So it could be that it could be collision avoidance. The result could be that collision avoidance in cases like this will be done more by a speed reduction than by a turning maneuver. So that is a possibility. So this is what we're looking forward to do in the coming year. So I hope that when we meet next year, we'll be able to present the result of these tests as well. And as Mats already said, we've had some extensive cooperation with the pilots and port authorities and DTS operators of the Humber East Rig. And we are looking also to do some tests with suggested routes in that area, not only no-go areas. So for instance, usually that was expressed by the Humber DTS was that ships are often sort of moored out here, anchored out here, and then as they want to approach, there is sometimes very heavy currents, up to 4 knots going in this area. and the pilot pickup position is up here. So ships, as they leave the area, they sometimes tend to misjudge the strength of the current. So these buoys up here are very frequently hit. So what the pilots actually, and the VTS at Head actually wanted, they wanted to be able to send out a suggested route, go to the pilot pickup area, but don't go straight. Make enough place to take care of the influence of the currents. So that is a user need, you can say. Another problem that they have is that as Matt showed you, they have actually 3 entrances. The deep growth channel is the northern channel in here, and you can see that in the northern channel, the deepest part is in the north part. So they have a problem when they're taking out deep growth ships out of that northern channel. They have to take the ship out against the traffic direction in the inbound lane, and then go over to the outbound lane here. So at the same time as ships coming in, you have problems. So these are things that are done today, and the directions are given over voice from stern head BTS. But the thing is that often happens is that if you have these kind of complex situations, and they tell us that inbound ships are asked to go in the southern part of the inbound channel. Southern part of the inbound channel. Quite an easy direction. What they instead do is that they go in the outbound direction. They go further south. They go out in the outbound channel. They misunderstand this message. So what they asked for was that if you have a ship that is going out this way, the inbound ship is going this way, you have an outbound ship in the same channel, they would be able to send out a suggested route, just giving the information. Please can you follow the suggested route, because you will have an outbound ship in your own channel. And then, as Matt said, there is things where we need to have the no-go areas, and I won't spend much more time on that. So thank you very much for that.
Cracking presentation, Thomas. Thank you very much indeed. A couple of quick questions before we break for coffee, ladies and gentlemen, please. Got to be a question after that. Thank you, Thomas. That's interesting, but in particular in that case study, if they'd seen the ship on the starboard side, if they just obey the rule of the road, you won't have to do all this predictive or all the rest of it. If you've got a ship on your starboard side, he's on a collision course, you alter for him. You don't need to know where he's going or what he's doing. You just alter course. Whether if you knew where he was going, it shouldn't make any difference, because you would still have to obey the rule of the road.
It's if everybody just followed the rules of the road, there would be no problems. I agree with you, but people don't follow the rules of the road, and there is misunderstandings. Why didn't anybody pick up the microphone and talk in the VHF, for instance? Ask about intentions. Do you actually intend to do it? Then there are some rules saying that a silent ship, a well-run ship, is a silent ship. If everybody just follow the rules of the road, there's no need to communicate on VHF. But it doesn't look like that. So that's why I'm coming here as a climatologist, not as a rule maker. I'm trying to understand why these accidents actually happen. And is there some way we can actually help the people on the bridge to become aware of situations which they should have been aware of, but they are not, de facto?
One question in the back, please.
Yeah, Thomas, thank you again. I know your presentation. And of course the case, there's a lot to discuss. There was communication, at least they tried to get in contact. I think the most important thing is that when we're looking especially at this case, we have to say at the very beginning, when you start your observation and your discussion, in this situation there was no risk of collision in sense of keep course and speed, and the other has to give way. No, not at all. The most impressive thing for us, as we observe only, is that they were able, by maneuvering, changing the course, and the others starting to reduce the speed and ending up in a bad rendezvous, which you would like to do that intentionally, you would have some difficulties to get that situation. Anyway, having this situation, and that is quite clear, shown by Thomas, we need some kind of support, not to say technical support or more training. It is quite clear, if we follow the rules, then this would not happen. What was the real reason behind, which is Thomas asking for, and how can we support, and e-navigation is about also the human element, how can we better support the navigators, how can we give a support that helps exactly in such a situation, not in the usual business, so when we are awake and when everything is fine, but in a situation, yesterday Oscar presented the thing, usual behavior, unusual behavior. So if we are able, if Thomas is able to filter out, this is a situation in which you usually have take action, but now it's a very same situation and you do not react, then give a warning, alert, whatever. This is a very simple idea to approach it, but something like that. We want to avoid collisions like that, and they, for whatever reason, happen from day to day in our today's business, unfortunately.
Thank you. Like others, I found it a very interesting presentation. I do have alarm bells ringing, and I think the debate that you could have around your presentation could last more than the 2 days you've got here on the road. My concern is that the measure that you're talking about will, if applied, actually reduce the compliance with the rule of the road, which is the thing that is the base safety relationship, defines the relationship between ships at sea. Why people don't follow the rule of the road is the issue. One of the perhaps answers is a lack of competence and training, appropriate training for the person on the bridge. If we bring in more and more systems, well-meaning systems intended to help, we're going to have suggestions that there is training needed for those systems. And the overall depth of competence and training in one area is likely to be reduced. And I think we run the risk of unintended consequences from trying to make things better. I agree with Harry Gale that the rule of the road is that that's the primary thing, and we should tackle compliance with the rule of the road. It's the same with IMO. If they have a problem, let's have a new regulation. The very fact that the original regulation wasn't complied with is ignored. There is a natural tendency to rush on to let's build new things on top rather than make what we've got work. Thank you.
Yeah, I think it's a very good point, and I think you're right. We tend to disagree. The accident report that I was picking up this information from very clearly stated that the accident was the fault of the human error made on the Gdynia, but it didn't help the accident because the accident was already there. And I was actually trying to, hoping that I'd be able to talk about the accident between the Baltic Ace and the Corvus that Alvin mentioned yesterday. That was precisely an accident. It's very similar. One of the ships is trying to help the other ships by somewhat just avoiding and turning a little bit to the port so the Corvus would not have to do a big evasive maneuver. Unfortunately, the accident report is not still finished, although it was in December 2012. So I didn't use this as an example, but this is precisely the same type of accident. And what we actually do with the unintended consequences of change is something that we have been looking for before, and I'm skipping to some slides there. I've shown this one in some other connections. We did a test with the intended routes, because with intended routes you of course open the possibilities of using the flashlight on your blinkers on your car that you signal you're going to turn left, and instead you go straight ahead and you actually cause a collision. So we've been trying to find these kind of instruments to do this. So this is from a simulation that we did in the early summer. This is a southbound tanker we're on board. It's actually approaching the narrow channel between Helsingborg and Helsingør, where we have all the ferries going over. And if we look a little bit ahead in the simulation, we can see that the Danish pilot is sitting here. He is looking at a situation that is developing in the area. There is a ferry coming out from Helsingør, sending her intended route. And here is the tanker north. If we zoom in a little bit on that picture, you can see the tanker somewhat to the starboard side of its own track, and we see the intended routes of the ferries. Now, what does the rule of the road say? The rules of the road. The tanker is the give way ship. So, what the tanker does in this case, quite contrary to, we haven't instructed them to do this, but what they do is they actually click and drag, they add a waypoint, they click and drag that waypoint close up to the port of of Helsingør to give a message, because their intended route is sent to the ferry, that we intend to collision avoidance and change the route. At approximately the same time, the ferry is maybe adding 2 waypoints to its route, dragging the second waypoint way aft of the tanker. This is in contrary to the rules of the route, but according to the traditions that is always done. The ferries always yield for ships from any direction in this narrow sound. And on board the tanker, they click and drag the waypoint back to the position where it is. So you're actually doing collision avoidance or collision negotiation. And you're doing it very well ahead of time. You're doing it before you're actually entering into a cool race situation. Because there has to be a time when you stop fiddling with your active screens and your computers and look out the window to the other way. So the point is, and the question we need to investigate in these kind of simulations is there unintended consequences of change that will cause new types of accidents? Or does it give us a second shelter, a second barrier to collisions that possibly could be avoided?
Ladies and gentlemen, this one will run and run over coffee. Thomas, well done. I think the point around rule of the road and collision avoidance is absolutely fundamental. My understanding of rules of the road, the rule of the road system we have at the moment, is it one-on-one situations once only. That stunning slide that you put up, Thomas, of, I don't think you put the East Anglia wind farms up again on top of the AIS, that one where they're going to kindly leave a bit of a narrow corridor through the centre of a oofing very big wind farm. One of the rules that we're going to test for countering collision in that sort of sea space. And actually, the tool that Thomas is describing could be called a rule of the road collision system demonstrator. And I don't understand why ships teams wouldn't want to know that predictive information. I spent my life sitting inside we used to call it a JUD display. It's a radar display, and it had a black cowling for use in daytime. You used to stick your hands in and use a sticky pencil, and you plotted the track that you thought was going to be on a potential collision with you, and then you predicted what its relative motion was going to be, and you got your second officer watch to plot it on the chart to try and work out what its course was, to decide whether or not you're going to have to alter for it. So this is being done for you using the digital database that's available to you. But the points you make about the anti-cold rates are really, really important, and they may be something that needs to be tested in ACCSEAS too. So there is this, I don't understand why ships teams wouldn't want predictive information. I simply can't compute that, because I think that's what ships teams should be doing all the time. And personally, I wouldn't let the officer watch of the Virginia sit down.